Good morning, this is your Stat Sensei, Mr. Spensei, and this is regression sentence stems for I Can't Drive 55. So an insurance agent reviewed the records of drivers at 12 different ages. That's going to be important. We'll talk about that here in a moment. To determine if there was a relationship between a driver's age and the percentage of accidents caused by speeding. The data table and computer printout for the regression analysis provided below. Awesome. So since we have that, let's go ahead and identify the important row. That's our y-intercept row, and this is our slope row. It says the first thing is write the regression equation and define x and y in the context of this problem. Well, in order to do that, I need to identify what y and x are. Right, real quickly, I see, oh, this is on my slope, so this is my x variable. So I know age is my x. Well, that means I can go ahead and put x here, and that makes percent of accidents caused by speeding my y. And so to be consistent, that's my y, and this is my x. And also, if we go back here, we see driver's age. That's our x. Percent of accidents is my y. Don't know what order it's going to show up. They can switch, but that's where, I mean, it's actually included in the prompt. We also see it in the data table, and we can figure it out if we identify age. So the key place to find that is right here with there. So we know that this right here is going to be my y-intercept, and this right here is going to be my slope. So my equation is y hat equals 64.7384 minus 0.96065x. But if you do that, it says the regression equation and define y and x. If you write it like this and just like this, you're going to have to go let y equal the percentage of accidents caused by speeding, let x equal the age of the driver. Or the quicker way is to go ahead and write it. And you don't, if you do this right here, you don't even have to do this. You go, okay, my y variable is my accidents. Cool. All right, so here's my accidents. This is my y. And then my x happens to be age. And please note this right here, that's my y-intercept. And this is my slope. And if you do it like this, you don't have to put any labels. You just write what we have there. All right, moving on. The next thing it is write the slope and explain its meaning and context. Oh, well, there's my slope. And please, oh, and even though I didn't highlight it, we have a negative slope, just like it shows negative there. So that's going to be really important. So um, okay, so we've already defined y and x, percent of speeding accidents, driver's age. We talked about where that came from. The next thing is slope. Well, first off, our slope is negative 0.96065. And that came off of the slope row. So there's a 0.96065 decrease. The reason we're using the word decrease is because this was a negative slope in percent of speeding. There's our y for every 1 unit increase in the driver's age. So this right here, driver's age, this is our x, this is our y. And by the way, when we write our sentences, we're always going to go yx, yx. And we see percent of speeding. Oh, that's what it says right here. Driver's age right here. So once again, we're being very, very consistent between y and x. All right. What's the next thing it asks for? Well, the next thing it asks for is write the coefficient of determination. Well, I need to find my r squared because remember coefficient of determination is r squared. and we look and we have two R squareds, but we'll never ever use this one. We only ever use the R squared that's not adjusted. So our R squared is 96.93. So 96.93% of the variation in the percent of speeding accidents can be explained by changes in the age of the driver. All right. So it can be explained. So 96.93%. This is just basically our old R squared that we pulled off of the table of the variation in the percent of speeding accidents. Wait a second. That sounds familiar. It should, because this is our Y. Misplaced a pen real quickly. Okay, this is my Y and the driver's age, which happens to be my X. All right, moving on. The correlation coefficient. Well, keep in mind, correlation coefficient is based on two things. It's based on sine of the slope, where our sine of our slope here happens to be negative. All right, so since we have a negative slope, we're going to have a negative correlation coefficient. I hope that shows up. All right, so this is a negative correlation coefficient, and that came from the slope. So I'm going to highlight it in pink because that's what we're using for slope. And then our R squared, we're taking the square root of 96.93. Turn it into a decimal, just in case you forgot. 96.93 divided by 100, 0.9693. And we're going to just raise it to the half power. And that's where we get to 0.9845, but don't forget to put the negative. All right, don't forget to put the negative there. So there's a strong, and if we were looking at our table, we'd go anything greater than 75% is strong, between 40 and 75 is moderate, less than 40 is weak, but this is 98, it's greater, so that makes it strong. Negative, the negative is coming from our slope. Linear relationship between the percent of speeding accidents and driver's age. Guess what? There's our Y, percent of speeding, and driver's age is our X. Once again, Y and X. Always, always, always go in this order of Y and X, and you can see how important Y and X is. The next thing it asks for is explain S. Oh, well, S is the standard deviation of residuals, and we have to find that. And we're just looking for an S all by itself, and here it is, 2.9916. So the standard deviation of the residuals is 2.9916. I just read that to you off the table. And it measures the variance in the percent of speeding accidents. Guess what? That's our Y for a given amount of driver's age, or for a given driver's age, if you prefer. All right. Anyway, hopefully you'll notice that um, if you identify your X and Y, by the way, for some reason this is swapped. I wrote this wrong. This is my Y. This is my X. I don't know how I did that. Y is accidents, X is age, just like we have here in the table. X is age, X is age, and Y is accidents. Sorry about that confusion. Not remaking the video. Anyway, I hope this helps, and I look forward to seeing you on the next one. Thank you. Actually, I want to go back and talk about the slope real quickly. One thing I find that really helps students and helps myself is if I take the slope and I make it into a fraction and I go negative 0.9606 over 1, and it'll always be over 1. Always put over 1, and then I always put my Y variable, which happens to be accidents, over my X variable, which happens to be age. So there's a 0.96 in accidents for every 1 unit increase in driver's age. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.